boys and girls. All right, moving along in chapter 7, we are on lesson 6, rename fractions and mixed numbers. Now this is kind of a whopper of a lesson because you could really separate this into 2 lessons where you could just rename fractions, and then another lesson could be on just renaming mixed numbers. But hey, we put them the book put them together, so we're going to do an excellent job of doing it together. Okay, you guys got this. So you know the word rename. Rename. Re means again, so we're going to name again. We're going to have a fraction and we're going to name it a mixed number. And then when we have a mixed number, we're going to rename it as a fraction. Okay? So on the 5, 6, and 7 that I have up here, boys and girls, the directions say write the mixed number as a fraction. Okay? So a mixed number, as I'm sure you guys know, is like 4 1/8. It's mixed because it's a mixture of a whole number and a fraction. Okay? So I'm just down here. I'm going to draw like 4, we'll call them cookies. Okay? I'm going to draw 4 cookies. That's going to represent my whole number 4. And then I'll do a little cookie piece. That'll be the 1/8 that's left. Okay? What I'm going to do with these 4 whole cookies is, look at that denominator 8. Remember what a denominator tells us, guys? A denominator tells us how many pieces make one whole thing. Okay? That's its only job. What makes the whole? And it gives us an idea of what the piece size is and all that stuff. So in 4 1/8, each of these cookies is made of 8 equal parts. So the first cookie has 8 equal parts. The second cookie has 8 equal parts. Third cookie, 8 equal parts. Fourth cookie, 8 equal parts. And then, of course, we have our little friend, the fraction of another 1/8. So that's 8 parts, 8 parts, 8 parts, 8 parts. That's 4 sets of 8 parts. Isn't it, guys? 4 sets of 8 parts of a cookie, if that's how you want to think about it. Okay? So when you look at your problem, you look at 4 sets of 8 equal parts. So what is 4 sets of 8? Let's do that math. 2 sets of 8. 2 times 8 is 16. Double 16, that's 32. So the whole cookies, the 4 whole cookies, that's 32 eighths. 32 eighths, right? That's 8 parts, 8 parts, 8 parts, 8 parts. So 4 sets of 8, that's 32 eighths. But then, don't forget our little piece of a cookie over there. There was another eighth. So we don't just have 32 eighths. We have this one more eighth right there. So what's 32 plus 1? I'll put a plus right there. What's 32 plus 1? 33. So 4 1/8 can be renamed as 33 eighths. Now let's just talk about that one more time. 4 sets of 8, which is right there, plus that one more eighth, which is right there. So 4 sets of 8 is 32, plus that one more is 33. 33 eighths. All right, let's take a look at number 6 now, guys. It's 1 7/10. Okay? So we'll imagine we have one candy bar, and that's the one whole. How many equal parts is that candy bar made of? Remember the job of the denominator? Yeah, 10. That whole candy bar has 10 parts, 10 pieces. And then, of course, we have 7 little random pieces of candy bar. 1, 2, 3, 4, 5, 6, 7. Okay? So how many tenths do we have? Well, there are 10 right there. And then there are 1, 2, 3, 4, 5, 6, 7 right there. So what's 10 pieces plus 7 more? 10 plus 7? That's 17 pieces. 17 tenths, right? Which we got right there. So you just again did, I have one set of 10 plus 7 more. 17 tenths. All right, now let's do number 7. Number 7 is the mixed number 5 1/2. Okay, 5 1/2. So let's do 5, I don't know, pizzas. 5 pizzas. 1, 2, 3, 4, 5. 5 whole pizzas. Okay? We are going to think about those pizzas as cut into 2 parts each. 2 parts because the denominator tells us that's how many parts make a whole thing. So that whole pizza has 2 equal parts. So does that one. So does that one. So does that one. So does that one. Okay? So 5 sets of 2 parts. Right there, guys. 5 sets of 2 equal parts. How many is that? Of course, it's 10, right? 10 parts. But then, don't forget, we have one more little thing to deal with there, right? That's one of those parts. That's half of a pizza. So we have 2, 4, 6, 8, 10, 11. We have 11 halves. Okay? 11 halves, 11 toothies, I don't know. We have 11 over 2. It's 11 halves. Okay? So we did 5 times 2 plus that one more piece. 5 times 2 is 10 plus one more is 11. And then, of course, what makes a whole doesn't change, right? That didn't change for any of these. 10 makes a whole, 2 makes a whole, 8 makes a whole. Excellent. Excellent job, guys. All right, let's keep going and doing some more renaming. So this, look at this. The directions for 13, 14, and 15 say, write the fraction as a mixed number. So these are fractions that they want us to write as a whole number and a fraction, which is a mixed number. Okay? So we are kind of doing the reverse of what we just did. So for number 13, let's think about what we know about fractions. We have 23 pieces. And what's the job of that number? That tells us how many make one whole thing. So let's see. I'm going to do squares. Well, the best square I can do, right? So that square is going to be the whole. Now, how many are in one whole? What did we just say? 10. So there are 10 in that one whole thing. Okay? How many pieces do we have to deal with here? Oh yeah, 23. So if we make one whole, we've only used 10 pieces. So can we make another whole? Let's see. What did we say? What's one whole? 10 pieces. So that's another 10 pieces. What's 10 plus 10? 20. So we have made two whole things, and we've used 20 pieces. Now, can we make another whole thing? We would need 10 more pieces. That would be 10, 20, 30. Do we have 30 pieces? No, we do not. We only have 23 pieces. So we made 1, 2. We made two whole things. And remember, we have 23. How many pieces do we have left? That's 20 pieces. So we still have 21, 22, 23. We still have 3 pieces left of the 10 that make one whole. So 2 and 3 pieces out of 10 that make a whole. So 23 tenths is equivalent to 1, 2 whole things, 10, 20, and 1, 2, 3, 23. 2 and 3 tenths. Now you may have learned in class today to think of it like division. It's exactly right. It is division. 23 divided by 10 is 2 and 3 tenths. That's the quotient to 23 divided by 10. You might think of it like how many tens, or I should say how many whole tens can I get from 23? No, that's not what I'm going to say. How many whole times can 10 go into 23? 10, 20. 2 whole times. With how many left over? 3. Let's do number 14, guys, okay? All right. Look at that fraction. 19 fifths. Do you want to think of it like division? How many whole times can 5 go into 19? Or you can draw a picture again. We'll do circles. How many whole things, how many pieces make one whole thing? 5. So there's one whole. But we have 19 pieces. There's another whole thing. That's 5 pieces. So 5, 10, 15. Okay, let me see. Can I make another one? 5, So 5, 10, 15, 20. Uh-oh. Uh-oh. I only have 19 pieces, right, guys? So sorry, you. We don't have enough pieces to make another whole thing. We made 1, 2, 3 whole things. 3 whole things out of the 19 pieces. We didn't use all 19 though, did we? So we used 5, 10, 15, 16, 17, 18, 19. How many pieces were left? 4 fifths. 4 pieces out of 5 that made a whole were left. 19 divided by 5 is 3 4 fifths. 5 goes into 19 3 times. 5 times 3 is 15, and then 16, 17, 18, 19. All right, now let's look at number 15. Number 15. Do you want to try this one, like division, and do like a long division? You could probably even mentally divide this, but let's write it out. So I'm going to say 11. Oh, I always forget this color doesn't work great. 11 divided by 3. So what we're thinking is, how many wholes can we make with 11 pieces if 3 make a whole? Okay, so let's see. 3 into 11. 3, 6, 9, 12. Oh, we don't have 12 pieces. Sorry. So 1, 2, 3. Right? So 3 times 3 is 9. Subtract 9, 10, 11, 2. So how many whole times can 3 go into 11? 3 whole times. With how many pieces left over? 2 pieces left over. Now watch this. I'm going to take my 2 and go boop. There is your fraction. 2 thirds. So we made a fraction a mixed number by using models, but talking a lot about division. And then we just did this last one with division. What do you think, guys? Yeah, you can do this. You're amazing. All right, we're down here at problem solving. Let me see here. Number 17. A recipe calls for 2 2/4 cups of raisins, but Julie only has a 1/4 cup measuring cup. How many 1/4 cups does Julie need to measure out 2 2/4 cups of raisins? So let me go back. You know what I'm going to say, and reread this. So when somebody says a recipe calls for, it's not like the recipe is yelling out, "Hey, I need 2 2/4 cups of raisins." A recipe calls for, that means that on the recipe it says it needs 2 2/4 cups of raisins. But Julie only has a 1/4 cup measuring cup. So she has a measuring cup, you know, those cups with all the lines on them. Ding, 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 ding. Her cup only holds 1/4, and that's it. That is all her measuring cup will hold. So how many times does she have to fill that 1/4 measuring cup to get 2 2/4 cups of raisins. So let me see here. She has 2 whole cups and then 2/4. So there's the 2/4. No, I shouldn't draw them like that. Here's the 2 whole, and I'm separating them into 4 equal parts. And then, so I just drew a picture of 2 2/4. Okay? So how many times is she going to have to fill 1/4 to get 2 2/4? Well, you guys, you can see it here, right? Isn't that a 1/4? And is that a 1/4? Is that a 1/4? Yeah. Is that a 1/4? So how many fourths are right here? 1, 2, 3, 4. So that's 4 times she's going to have to fill the cup. And then 1, 2, 3, 4. 1, 2, 3, 4 times there. And that's a 1/4. And that's a 1/4. 2 times there. So Julie is going to have to fill her measuring cup 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My goodness. She's going to need 10 1/4 cups. Now that's not a subtraction sign, you guys. That's like I didn't want it to look like 10 and 1/4. Okay, it's 10. 10 is really the answer. 10 1/4 cups. So guys, what did we just do? We looked at 2 2/4 and we changed it. Excuse me. We changed it into a fraction. We renamed it into a fraction. We knew it was 2 sets of 4. Look, 2 sets of 4 plus the 2 more. What's 2 sets of 4? Right there, right there. 2 sets of 4 equals 8 plus those 2 extras, 9, 10. 10. We needed 10 fourths. 10 of those 1/4 cups. Whole number times the denominator plus the numerator. Whole number, 2 sets of 4, there are the 2 whole things into 4 parts, plus our little extra friends right there. Awesome. Let's keep moving, guys. You're doing fantastic. Oh, let's see here. Lesson check. This is on the back. Which of the following is equivalent to 16 thirds? So how do you want to attack this, guys? Well, I'm gonna divide, but I'm gonna do it this way. How many sets of 3 till I get to 16? There's 1 set of 3. I'm not at 16. 6, 9, 12, 15, 18. Oh, I don't have 18 pieces though, do I? How many pieces do I have? I have 16. So farewell to you. So guys, each one of these sets of 3 is 1 whole. Okay? One more. One more. These are really, that's 3, 3. But I was writing multiples to keep track. 3. Okay? 1 whole. 1 whole. So how many sets of 3 can I get out of 16? 1, 2, 3, 4, 5. 5. 16 divided by 3. 3 goes into 16 5 whole times, right? Did we use all our pieces? Nope. We only used 15 of the pieces. How many do we have left? 15. What do we have to start again? 16. So we have 15, boop, 16. We have 1 out of the 3 left. And look over here. 3 times 5 is 15 minus 1. Whole number 5, fraction 1/3. So each of these circles is one whole thing. That's 3 pieces. That's 3 pieces. How do I know 3 pieces makes a whole? Because 3 is the denominator. That's 3 pieces. That's 3 pieces. And that's 3 pieces. And I was writing 3, 6, 9, 12, 15, just to keep track of how many pieces I was using each time I made a whole. So I have 1, 2, 3, 4, 5 whole things and 1/3 left. And here it is as division. 16 divided by 3 is 5 and 1/3. That's using the remainder to make a fraction. Isn't that awesome? 5 and 1/3. You guys are amazing. Whew. Oh my goodness. Look at the review problem. This has fractions in it too. This is chapter 6, lesson 5. Oh, we can do this. During a bike challenge, riders have to collect various colored ribbons. Each half mile, they collect a red ribbon. Each 1/8 mile, they collect a green ribbon. And each 1/4 mile, they collect a blue ribbon. Which colors of ribbons will be collected at the 3/4 mile marker? Okay, wait, I got to go back here. Well, I'm just glancing at these choices. Red and green, red and blue, green and blue, red, green, and blue. Okay, so they're definitely getting more than one ribbon at the 3/4 mile marker. I'm going to reread though. Riders have to, okay, so they collect various ribbons right here. Each half mile, they get a red ribbon. So I'm going to do a little track right here. And at the 1/2, what do they get? Red. They get a red ribbon. I'm going to put an R there. Okay. Each 1/8 mile, they collect a green ribbon. So a green ribbon is every 1/8 of a mile. So I'm going to separate this mile on my little track into 8 equal parts. So there's 1. Let's make sure I did that. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So at each of these, yeah, each 1/8, they get green, green, green. Does this count as one of the 1/8 jumps? It sure does. Green, 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 green. Oh, they probably get a red there too at the end, right? That's another half a mile. Okay. So are you thinking, why did Mrs. Olvey put a green ribbon here at 1/2 when it was really 8ths? Well, remember guys, 1/2 is equivalent to 4/8. right? 4 is half of 8. So 4/8 is equivalent to half. It's exactly the same place on a number line. So they get a green ribbon there too. All right, let's see. They get another color. Oh yeah, they get a blue ribbon. Each 1/4 mile, they get a blue ribbon. So 1/4 mile, boom, 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 right? 1, 2, 3, 4. Okay, so blue ribbon. Oh, look at this, guys. They get a blue ribbon here too. And why is that? Because 2/4 is also equivalent to 1/2. So at the half, they get blue, red, and green. Wow. All right, so they get blue here, and they get blue here. Okay. That's a lot of ribbons, my goodness. All right, let me go back and double check. Look, what are they asking us again? Which colors of ribbons will be collected at the 3/4 mile marker? Okay, so when we divided this mile into 4 equal parts, do you see it right here? 1, 2, 3, 4. So that's 1/4. That's 2/4. I already put that. Right here, that's 3/4. Oh, what do they get at the 3/4 mile marker, boys and girls? They got green and blue. Is that one of the choices? Yay! They get green and blue. Woo! Boys and girls, that was tricky. We were really organized though, weren't we? I love drawing diagrams to solve problems like that, guys. You did excellent. Excellent, excellent. So guys, you can do this. This renaming fractions and mixed numbers, you got this. Just think about what it means. Think about what fractions mean, and you got it. All right. Have a great night, and good luck with the rest of your homework.